In this video, I'm going to show you how I collected the data for the ball dropping experiment or the ball dropping activity I assigned for this week. So the idea really came from, for this project, really came from studying the way Galileo figured out that objects fall at a constant rate. And this led to the discovery of what we now call the inverse square law. So I thought it would be fun to try to reproduce some real world data in my own yard. So as it turns out, I happen to have some scaffolding available. And I set up, 3 sections of scaffolding. This is about 17 and a half feet. And what I have in my hand there is a ball, a tennis ball. And one of my assistant, my son, has my digital or my cell phone, my smartphone, and he's using the video camera. And this is a slow motion option that we have. So this is really kind of cool because Galileo didn't have anything like this back in the late 15th late 16th, early 17th century when he was collecting his data. And the way Galileo did it is he would roll balls and things like that down ramps. And that's because they would be moving slower, still under the same effects of gravity, but just rolling slower so he could more easily time figure out how far the ball had rolled down the ramp on particular time intervals. But today we have this really great technology like cell phones and cameras integrated into our digital cameras integrated into our phones, things like that. So in any case, I'll just play this video for you so you can see it. So you can see the balls dropping in slow motion. And if you look really carefully, you might see the acceleration of the ball, that it's speeding up. If you look really carefully here. Let me play it one more time. It's moving slower at the top. Now, one of the things that I wanted to do is demonstrate to you how I actually collected this data. And so I have the original video here in QuickTime. I'm a Mac user, so I'm using QuickTime. And the speed of the camera is 30 frames per second. So every 10 frames is a third of a second. And so what I can do is move a frame at a time. You can see the ball moving. So I'm going to go back here to right when I release the ball. It's right about there. And I'm going to count off 10 frames. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the ball hasn't really gone very far in the first third of the second. So then I'll do another third of a second, 10 more frames. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the resolution of the video isn't really that great, but there are some numbers you can pick out. Like there's clearly a 7 here, a 6 here, 5, 4, 3, 2, 1, and then 0. And so I marked off this strip of paper with 1 foot intervals, and then in between I put another line at in between each foot for 6 inches. So each line is 6 inches of distance that the ball's dropped. And so I can estimate how far the ball's dropped for each 10 frame interval, which is 1/3 of a second. Here I'll do another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's another third of a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as the ball gets down towards the bottom, it'll become really noticeable that the ball's traveling more distance for every 1/3 second time interval. See, I'll do some more here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's about halfway through the fall. And you can see it's traveling quite a bit more distance for every equal time interval. So another 10, another third of a second, another third of a second, another third of a second, and it's basically at the bottom. So by doing this, or by using, again, my cell phone, I was able, and a slow motion option on my digital camera, I was able to collect the following data. And so what I've done is, again, estimated how far the ball dropped using my setup, the scaffolding with the paper, ribbon with all of the different 6-inch distances marked off. So what I'm going to have you do is draw a really accurate graph. Now, the interesting thing about it is to see what Galileo saw really requires drawing a very careful graph. And so I would recommend using graph paper for this assignment and really being careful about making sure you have the time scale on the horizontal axis marked off correctly, and then the distance on the vertical axis marked off. Using graph paper here is a really great idea. And you can find graph paper free online. There's many different sites that you can find it. Here, just for the heck of it, I'll go to the internet real quick. You can see I'm doing some research here for other things we're working on. But I'm just going to type graph paper, and a bunch of different options come up. Looks like my internet's a little slow right now. And so, again, this one actually might be a good choice. So again, you can just find this graph paper online, print it out, and then put an axis, put your horizontal axis, put your vertical axis, and then you can really be careful about getting everything scaled correctly, so you can actually see what you should see. And that's part of the activity. So I don't want to let the cat out of the bag here and tell you what you should see. I'll just leave it for you for now, and then I'll have a follow-up lecture after the activity to kind of explain. I'll show you the graph I drew and kind of explain what you should be seeing. Well, that does it for this video, so I'll see you next time.